Okay, so this is A-12, and we're going to do these 3 examples together. And help yourself to hard copies. They should be like in the middle of the room. So this first one, and this is going to be very similar to yesterday, A-11, except with one additional move. Okay, so this is, there's just like an opening move that we have to do. Okay, so all of the cases that we're dealing with today, the base is one of the bases, at least one base is a fraction. So when you have that, guys, what you want to do, whichever base is a fraction, you are going to flip the base. So 1 over 5 becomes 5. And we can do that as long as we negate the exponent. So you have to multiply the exponent by -1 in order to do this. But yeah, that's the very first move is flipping the base. And then, okay, so you just make it another problem that doesn't involve a fractional base. And then it's just like yesterday. So off to the side, 5 is equal to blank to the blank. 125 is equal to blank to the blank. All right, so I'm taking both of the bases, and I need to express them each with the same base. So 5, so I could use 5 for both bases, because that's 5 to the first, and this is 5 to the third. Okay, so this side isn't really gonna change, but 125, I'm gonna replace this entire side with 5 to the third. Okay, so now we have the same bases, and so -x is equal to 3, and then you divide both sides by -1. X is equal to -3. Okay, so that's the first one. Now the next one. So let me write it down. It's hard to see. -3x plus 3. (16 to the x plus 1). Okay, so again, before we even want to think about getting common bases, if one or more bases are fractions, or if one or more of the base, or sorry, if you see a fractional base, the very first move is to flip the base, but you can only do that if you multiply the old exponent by -1. Okay, and then this is 36. Okay. Alrighty, and now I'm going to go off to the side and find a common base. So I've got 36 equals blank to the blank, 16. And guys, to figure this out, you might have to play around in the calculator a little bit. But the common base here is 6. Okay, 36 is 6 squared. And then 216, is that 6 to the third? I think it is. Yes, okay. And then this is 6 to the third. So we can express both of these old bases as in base 6, with base 6. So I'm going to leave blank parentheses because I'm going to replace both of them. Okay, so this old base was 36, and according to our side work, we can replace 36 with 6 to the second. Okay, and then 216, that was the old base, and according to our side work, we can replace it with 6 to the third. Okay, now I'm going to do a little extra move right here. So I'm going to do a move where I keep the base and I multiply the exponents. Negative 6x plus 6. And then negative 3x minus 3. Okay. So guys, some of you might go right to the next step, which is fine, but I'm going to show this whenever as the teacher, am doing the problem. So now the bases are the same, and so I can set the exponents equal. Okay, so x equals 3. Yeah, so this move right here, you can skip it and go right to setting the exponents equal, but you have to be careful to distribute if you're going to do that. Okay, one more problem. So this is the last problem, and we're going to have to flip both of the bases this time. All right, so this is number 3. And okay, so the very first move, I'm going to flip that base, and then it's going to be negative 4x minus 8 equals, and then I'll flip this base, but it's going to be negative 3x minus 3. Okay, and then I go off to the side, and I figure out how to rewrite these using the same base. Okay, so 125, I know that's going to be 5 to the third. You know, I could make that 5 to the third. Oh, you know what? 125 to the second. 125 to the third. Okay, never mind. So when you take the bases to the side, guys, it never hurts to check to see if the bigger base can be expressed using the smaller base. Like that's why I was just checking 125 to the second, 125 to the third, but that's not even close. Okay, so I could make these both bases of 5. So 125 is 5 to the third, and then this number, you'll just want to keep plugging in. So 5 to the third, 5 to the fourth, 5 to the fifth, 5 to the sixth. Okay, I'll try 5 to the eighth. Oh, that's too much. 5 to the seventh. Oh, it was the one I skipped. So 5 to the seventh, right there. Wait, that's hard to see. Okay, now I'm replacing both bases. So I'll go like this. Okay, according to my side work, I could switch 125 with 5 to the third. And then I could switch this number with 5 to the seventh. Okay, now I'm going to do another move where I simplify a little bit, but I keep my bases. So 5 to the negative 12x minus 24 equals 5 to the negative 21x minus 21. Okay, and now I'm going to set the exponents equal. Okay, and then I add, I think that's right. Okay, and then I add 24, 3. So x is 3 nines, x is 1/3. Okay, let me check the solution because that was actually number 6. Yes, okay, so I got it right. Okay, guys, there you go.